guys, it's Team Adaptive Learnings again. In this video, we will discuss the SIP loads, weather, and residential loads in a GridLAB-D. So let's get started. What is SIP loads? SIP loads is a representation of load with three distinct parts, such as constant impedance portion, constant current portion, and last is constant power portion. Each of these portions responds differently to changes in load voltage. For constant impedance, the power to be reduced as the square of the voltage change and current to reduce linearly to the voltage change. For the constant current, both the power and the current to reduce the linearly with the voltage change. For the constant power, the power will remain unchanged and the current will increase linearly with the voltage change. To better understand this portion, let's take a look at this example. So this is the default way in the defining a load. As you can see, there are the three portions of load: the constant power A, the constant current A, and last is the constant impedance A. This is the default units for these values, which are the watts, the ampere, and also the ohms. Also, there is an alternative way in defining a load. Here is the example. Other than defining the GridLAB-D, also enables us to simulate the weather in our model by the use of object type called the weather. This weather object contains a larger number of parameters, such as the temperature, the humidity, the wind speed and the direction, then the solar radiation, air pressure, and many more. But these data are not typically defined manually, but instead by the use of what's so-called TMY data sets. So what is TMY data sets? TMY data sets stands for typical meteorological year. It is a collection of dated files define a comprehensive set of weather parameters for a given geographic location. There are two types of TMY files, such as a TMY2 and a TMY3. The TMY2 is the older set of files with more limited geographic coverage, while the TMY3 it is the latest versions of data with a broader range of geographic locations. Also, it is in a CSV format. So you can access these files in this link from NREL, http://www.nrel.gov. So there are the links for the TMY file and also the TMY3. To use these TMY files, simply import the module climate and define this object. called the climate, which is this is the parameters that we can use, which is we use the TMY file, and then the path of this TMY2 or the TMY3 that we call, and it will know the simulate the data inside that TMY2 or that TMY3 to the model. Okay, next is the residential loads. Other than these fantastic features of GridLAB-D, it also has a residential heavy distribution circuit modeling, which is called the house class, which is shown in this diagram. So this class is integrated with a heating and cooling models, which will be activated based on the weather outside. As the outdoor temperature rises, the indoor temperature will gradually follow up, thus activating the air conditioner and increases the loads to the electrical system to define a house class. So see this example. First, you need to specify its name and its parent meter. And then for the thermal integrity level, use this table. So we can see the HVAC power factor we set, which is in this example, is set to 0.97. And then the cooling cup is the system cooling performance of coefficient. And then next, the parameter of a object house is the thermostat dead band is set to thermostat control, which is number 2. And last is the air temperature, which is we set as 72.5 degree Fahrenheit. So after we know all the concept of SIP loads, the uses of the object house, the loads, the TMY datasets, and also the residential loads, so that's it for this tutorial. Thanks for watching this video. If you want to see more of this content, be sure to hit the like and subscribe the button and visit us at our channel, and see you guys in the next video. Bye for now. See ya.